This is the 2010 question 2 relative velocity. Two particles A and B start initially from points with position vectors. Here they are, their relative positions, and their velocities are 4i minus 3j and 5i minus 7j. First part, find the velocity of B relative to A. The velocity of B relative to A is the velocity of B minus the velocity of A, which is equal to 5i minus 7j j, 5i minus 7j minus 4i plus 3j. Changing the signs, so we're going to get 5i minus 4i, which is I, and minus 7 plus 3 is minus 4j. The velocity of B relative to A. The magnitude of this is equal to root 17, root 1 plus 16, and the direction is equal to the inverse tan of 4 over 1, which is going to give 75.58 degrees, and we're in positive negative territory here, so positive negative is south of east, so south of east. In part 2, show that they collide. So for them to collide, we have to show that their relative positions, so the relative position of A is this 6i minus 14j. So we have to show that the relative position of A relative to B is going to be a constant times the relative velocity of A relative to B, or B relative to A. So 3i minus 2j is B, so the relative position of A relative to B is going to be equal to the relative position of A minus the relative position of B, which is equal to 6 minus 3, which is 3i, and minus 14 minus minus 2 is plus 2, minus 12j. Turn your phone off when you're studying, which is equal to 3 times I minus 4j. Therefore they collide. You can also say that the angle here, theta, is equal to the inverse tan of 12 over 3, which is also equal to your 75.58 degrees. So these two definitely collide, and this constant in here will be when t is equal to 3.